Hi students, in this video I will be talking about what is a standard deviation, what is the importance of it, and how to calculate it in a sample and later on in a population when the frequency is either 1 or not equal to 1. Okay, so the standard deviation is the average amount of variability in your data sets. It tells you an average how far each point or each value lies from the mean. So if you consider this graph, if this is your mean, so standard deviation will tell you whether you are here, here, or here. Okay, so when the standard deviation is high, okay, that means you are far from the mean, and when the standard deviation is small, that means you are around the mean. Okay, so what does it actually, a standard deviation, tells you? Remember guys, like in the first few sessions I told you about the normal distribution curve. This is a normal distribution curve which you start from low, you go to a maximum, and then you move toward low again, right? So at the two extremes you are very low, exactly in the middle you're at the maximum, and the curve it's like a bell shape, right? And then it is maximum exactly in the middle. So in the normal distribution, data is symmetrically distributed and there is no skew. Okay, so most of the values cluster around a central region with values tapering off as they go further away from the center. So as you can see in this graph, most of your values are in the darker region, right? Which is one standard deviation around the mean. So let's say if for this specific sample or population your mean is at 0, your standard deviation would be exactly, let me show it here, your one standard deviation to the right and one standard deviation to the left would have a good amount of your data. And remember guys, I told you before, knowing where most of the population or sample are, it's very important for us. Okay, and we also know that many scientific variables follow normal distribution, such as height, test scores, or job satisfaction rating. When you have the standard deviation of different samples, then you can compare their distribution using different statistical tools or tests, which we will talk about them later during the course. So here I brought you another graph of the normal distribution with different colors. It's exactly the same thing. You can see again it's a normal distribution, bell-shaped, symmetrical around the mean. So the mean doesn't necessarily need to be 0. It could be any number. So why is it so important? In a normal distribution curve, around 68% of your total data, it's one standard deviation around the mean. So if you move one standard deviation, if you calculate, first of all, if you calculate the standard deviation of your sample and you move one standard deviation to the right and one standard deviation to the left from the mean, it would contain more than half of your data. Now, if you move to a standard deviation, okay, let me get my pen. If you move to a standard deviation this time, let's say this is your mean, you move 2 standard deviation to the right and then 2 standard deviation to the left. So it will contain 95% of your data. And also if you move again 3 standard deviation around your mean, it would contain about, it will contain about 99.7% of your total data, which if you compare with the 100%, you would see that it is the majority. It's almost 99.7% of your data out of 100%. Next, we want to talk about how to calculate the standard deviation for a population versus standard deviation for a sample. As you can remember, in the previous session, I said we don't have access to the population, right? So we run our test and experiments on the sample. We find all the features such as mean, mode, uh, standard deviation, and later on we will modify the values and then attribute it to the population. Okay, so now I would introduce some formula for a standard deviation for sample versus population when the frequency is 1. So next step is actually calculating the standard deviation. Okay, now we want to calculate the standard deviation. These are the formulas from your formula book that I copied here. As you can see, the first two formulas, there is no mention of frequency. So it's assumed that the frequency is 1. But let's say if you have a frequency distribution table, or your frequency is not equal to 1, then you have to take that into consideration. That's why in the third formula there is f in the formula, and you have to consider the frequency. Okay, so here I brought two different things, sample versus population. As you can see here, the S stands for standard deviation of a sample, and this is the formula that you can use. And if you compare it with these two formulas on the top, it's exactly the same thing. This formula is exactly the same as this thing. These two formulas, which I copied here, these two next to one another, they are different forms of a standard deviation for a sample. As you can see, this one is, they call it a shortcut because people find it easier to use this one. And actually it would have less amount of calculation. And I will teach you how. But remember, the S stands for the standard deviation of the sample, and then there are different formulas. Okay, so in this formula, the X, all right, it's the value in the data distribution sample. Okay, the X bar is the mean of the sample. So you guys should know how to calculate the mean or the average, and N is your total number of observation. Just to give you a reminder, if you don't remember, this is the formula you have to use to calculate the mean. Okay, so X bar, which is your mean, is the sum of all the data points divided by the total number of data points when they all have the same frequency. But again, sometimes they don't have the same frequency, right? They might have different frequency, like some numbers might repeat itself, like it might repeat a couple of times. So in that case, again, if you refer to your formula book, there is another formula which there is the mention of frequency. So these two formulas are used to calculate the mean. Okay, so you can use these two formulas to calculate the mean. And I'm gonna repeat myself just as a hint or as a side note here. For these two formulas on the top, okay, you will only need this one to calculate the mean because frequency is already 1. Okay, so when the frequency is 1, okay, when there is no mention of frequency here, there is no mention of frequency here either, right? But when we have a frequency less not equal to 1, then you have to take that into consideration. So here we have frequency term, frequency term, frequency. Okay, So from now on, we will focus on calculating the standard deviation of a sample. For now, we are not concerned about the standard deviation of the population, just a sample. And we use the letter S, to show the standard deviation. We will do, for the rest of this video, we will do some examples. So here I've just put down some steps for you guys if you want to calculate the standard deviation of a sample when the frequency is 1. Okay, so here I'm gonna bring down the formulas again, so you would know exactly which formulas to use. So first of all, you have to use this formula to calculate the mean of the sample, which is basically adding all the numbers together or data points together divided by n. So that this is the first step. Then for the second step, you will be subtracting the mean from each data point or from each score. Okay, this is x minus x bar. Then in the next step, you will be squaring each deviation. What I mean by deviation is x minus x bar. Okay, so after calculating each deviation, you raise it to the power 2. Then the next step would be dividing, okay, at the squared deviation, right? After that would be dividing the sum by the number of scores minus 1, which is n minus 1. And step 6 would be taking the square root of the results from step 5. Okay, so these are the steps that you have to take. These steps are for this formula. Okay, these steps are the steps that you need to take for using this formula. Now I'm gonna so let's start with this data set. So you have a very small data set consisting of 4 numbers. The first step is calculating the mean, right? So what you have to do, first use the formula to calculate the mean. Okay, basically here you just have to do what? Yes, that's correct. So here you just have to add all the numbers together to calculate the mean. Okay, so if I want to calculate the mean, the mean of this sample is 3. Now the next step is calculating, right, x minus x bar, or the deviation. Okay, so as you can see in the next step, these are my data points. I subtracted from the mean and then raise it to the power 2. Okay, now I have these values for all the 4 data points. Okay, so subtract the mean from each score, which is step 2, and then I did a step 3 as well, which is squaring each deviation. Okay, that's what I did. Now the next step would be doing what? Yeah, as you just mentioned, the next step would be calculating, right, the sum of all of these deviations. So you add all of these numbers, so 9 plus 1 plus 0 plus 4, which adds up to 14. That's the next step, right? The very final step would be what exactly? Yes. Yes, the next step would be dividing, right, which is 14, dividing by n minus 1, which is 3, right? Whatever the value is, in the very last step, you take the square root. And this is your standard deviation of the sample. Okay? So this is how you can calculate the standard deviation of your sample. Ironically, we never calculate, like a statistician, never calculate a standard deviation by hand. Is just wants to give you an idea of how the calculation is done and to give you a better insight. Otherwise, for real examples or real research, We never sit down and make tables and do all these calculation by hands. We either use the scientific calculators or softwares. Okay, let's do another example. Here, the problem is the length in seconds of 13 songs on the album are these numbers, and the question is asking you to calculate the standard deviation. So what you have to do here, first you have to calculate, the first step, remember guys, is to calculate the mean. Okay, so first thing first, calculating the mean. This is how you can calculate the mean. Remember, you add all the data points together, divided by n, which is 13, and it comes up to 223 something. Okay, now the next step, right, is to calculate the deviation from the mean, and then raising it to the power 2. So as you can see here, I had 13 different data points. For each data point, I subtracted from the mean. Then the answer is raised to the power 2. So I calculated all of these values. The next step is simply adding all these values together and then dividing it by 12. So for the very next step, you add all of these value and you divide it by 12, and I want you to actually do that, and your answer should be, if you round it up, it would be something around 100, more than 130. Okay, now here let's continue with another example. Now I have another data set consisting of 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see, some of the numbers are repeating twice. Okay, so here what you can do is to either consider the formula having f on it, or following the same steps, right? For this one, you can calculate this formula to find the average, and then find this one, use this one to calculate the standard deviation. Okay, or because it's a very simple, small database, you can follow the same steps that I just mentioned. So I will show you how I solved it. For this specific one, the first step was calculating the mean, right? So this is how I calculated the mean. I added all the data points, as you can see here, divided by n. So number 17 was repeated twice, so I just wrote it twice. Or if you want to use the formula, which the frequency on it, instead of 17 plus 17, you can simply write 2 times 17, right? But the answer, the final answer for the mean, should be exactly the same thing, which is 16. The next step, remember guys, is to calculate the deviation, right? And then raising it to the power 2. This is what I did. I considered each point, subtracted it from the mean, and raised it to the power 2. Again, here for 17, what I did, I calculated twice instead of just calculating it once and times it by multiplying it by 2. So this one was a simple, easy one, because only one of the numbers, one of the data points was repeated twice, and the frequency was 2. If you have a data point which is quite large and there are more than one data point which is repeating more than once, you better completely rely on the formulas which have the term which frequency on it. Okay, now back to our example. The next step for calculating the standard deviation is adding all these numbers together, right? So that's what I did. I added all of these numbers. Okay, that was uh, the next step. Now I have to remember divide the sum, which is 586 by, yes, n minus 1. Okay, so the n was 10. Now I have to divide it by n minus 1, which is 9, and the final answer is 65.11. Am I done yet? No, because the very last step, it's taking the square root, right? So now I take the square root, and this is the final answer. Okay, so when I give you an example, what I want you to do is to exactly follow these steps. It will really help you not to make any examples, not any mistakes, sorry. Okay, so now we will continue with a scenario which we have a frequency distribution table.